All right, so yeah, thanks everyone for coming. So what Gabby and I thought we might do is have kind of a information session, almost like a forum, since I want it to be interactive and Q&A as much as I can, to talk about the Masters in Computer Engineering program. I'm assuming most of you are, well, I guess, new into the Master's program, or possibly now this would be your third semester and thinking of switching into the Master's in Computer Engineering from a different master's program like MSEE. We have quite a variety of master's programs. We have the general master's in EE. Then we have more specialized masters, and we just did a new one, I think, in machine learning and data sciences. And we have older ones in masters in VLSI design. Computer architecture is a recently done one. I think we have one in networks, I'm not sure. And then computer engineering is more of an overarching one that sort of has a sprinkling of all of those. When I think of computer engineering, I think of, let me tell you sort of what kind of jobs you might be doing. So in the VLSI area, you're building the hardware that people are using. So it's computer engineers, in my view, that would be designing the next generation Apple CPUs, accelerators, GPUs. It is computer engineers that generate the next IoT devices, the next Fitbit, low power things. It could be digital, it could be some analog as well. It could be mixed signal. So it could be application specific, it could be FPGAs. So that's one angle of it, of computer engineering, building the hardware. That's also in MS VLSI design, but a computer engineer will, and we want you to understand a little bit about building hardware. There's also the CAD side of things. This is software programmers who build the software that hardware designers use. In other words, when you're trying to build a hardware with 1 billion transistors, you can no longer do it manually. And the software programs to do that tend to be very, very sophisticated. Millions of lines of code, highly complex. And so students need to understand CAD algorithms, well, software engineering basics, C, C++, Python, but also algorithm complexity. A lot of the master students will take CS 570, and though it's not officially part of the curriculum, I generally wave it in. I think it's a great class. There's EE 581, Mathematical Foundations for Computer Engineering. And there's also several other CAD classes. 658 is a quite popular CAD class on test. So there's that angle, and those are good jobs. You need, the unique aspect is you have to be good both at software, you need to understand algorithms, and you need to understand the hardware that you're building. And it requires sophisticated talent. So there's those angles, and the kind of people who build that, that'll be the Synopsys, Cadence, Mentor Graphics of the world. And then to some degree, people will use the tools out of those companies to build chips. And the Apples of the world, NVIDIAs of the world will be using those tools and maybe doing some small customizations in the scripting world using those tools. Then there's the computer architecture folks. They will come up with new ways at the block level, not all the way down to the transistor level, but at the block level, at the microarchitecture, at the architectural level, even at the cloud level, how to put these systems and chips together. And now we've got a variety of computer architecture classes, from microarchitecture, which is basically how you might build a single CPU, to architecture, where you're now thinking about multi-core CPUs, GPUs, and accelerators, all the way up to cloud computing and how the software and infrastructure in the cloud would work. how you handle privacy in those domains, how you handle security in these domains, and a range of that. So, and these are very popular courses that we have, and I'll go into the specific courses in more detail. These people could be your principal architects at Intel, thinking about the next way that they want to generate this, or even at NVIDIA, or even in Apple or Samsung or other companies like this that will be architecting the next generation systems and chips, but at the block level. And someone else will then code it up in RTL and implement it further. They're looking at a little bit higher level of abstraction. And then one more level of abstraction up is the networking, how these things all talk to each other through either, CPU to CPU communication, to wireless networking, broadband networks, and things like that. I'm not a networking person per se, but we do have a variety of networking, and you should know that networking is split here at USC. There's a lot of networking courses and faculty here in computer engineering, as well as there's some in the CS department. And as a consequence, sometimes we do allow CS courses in there, and I'll go into the details on all this. So computer engineering can, spans, as I said then, from VLSI and CAD to architecture to networks, and it's got a lot of foundations to it. And basically, we expect students to be good at software, but certainly also hardware and understand the hardware. So compared to a computer scientist who may not really fully appreciate the hardware that their software runs on, the computer engineer will absolutely understand the hardware that they're using, how to leverage the hardware, if not how to design better hardware. But everyone should know some amount of programming, in my view. And this is also why I encourage so many computer engineering students to have a good, strong background in programming. Let's see. Okay, so that's sort of an introduction, I would say, to computer engineering and where I see it fitting. How it matters, I mean, if someone asks me, and I have had students ask me, well, I have a choice. Should I do master's in general electrical engineering or a master's in computer engineering? This is really, I mean, you could take many of the same courses and get a master's in EE. Computer engineering says you're a little bit more specialized. You're going to have a balance of software and hardware. It signals to your future employees that this is where you are and this is what you want to be. And it allows you to take maybe a little bit more CS than a master's in EE. Compared to, let's say, machine learning is quite hot. The computer engineer will understand aspects of machine learning. We cover it in some of our classes. Hopefully, you would be the people who could build the next machine learning accelerator. And if you wanted to take a machine learning class as part of elective, we would certainly encourage that. So that you could be the bridge between the algorithms and the math of machine learning and the hardware that it runs on. And that's a pretty hot area right now. I myself have been involved in startups and other activities to build hardware for machine learning. So there's the connection to machine learning. There's also connections to wireless networking and building hardware for that. We've done that in the past and still have courses that kind of cover those topics. So we see us as sort of like, well, I like to think of this as sort of the hardware hub of all these different applications in different areas of electrical engineering, computer science, because they all need hardware to run on, right? Some people don't think about it, but in the end they do. And I think it's increasingly important that we understand that. And even in the evolution of where we're going, given that Moore's law kind of tapering off, understanding the hardware probably is going to just be even more important, because you might need to now, to get future gains, might need to tailor the software more and more to what the available hardware is. So yeah, so the question, what is the difference between EE and computer engineering? The CE is a little bit more CS-y. We have a little bit more opportunities for CS courses. It's going to be a little bit more specialized into VLSI, architecture, and networking. And I'll go over the specific requirements now. But you know, if you could do it, yeah. And the only difference is that the fact that it says computer engineering on your degree signals to your employers that you're interested in that boundary between software and hardware, right? That you're thinking about this. Compulsory subject. So let's go to that. On the chat, you will see that Gabby put a link for the catalog page. And I'm now already have it there. So I'm going to share my screen and we're going to go into exactly what's required. Okay. So this is the most recent catalog page. And there are small tweaks, but every year that we make, we get a lot of feedback from students in terms of, hey, could this course be counted? And in a lot of cases, I make it happen. I can sign off on special cases. But when I see a repeated request over the years, we said, well, maybe we need to make that part of the program, make it default. And that's why the program, and then we have new courses, it evolves each year. Okay, so let's cover what we have here. So it's 28 units required. Okay, the non-EE courses require approval. And there is a process for that, and we're generally quite flexible. That's kind of also like the EE program. No more than 12 units can be at the 400 level. Right? 20 units must be computer engineering. So this is the specific, what's required. And that computer engineering is defined here: computer architecture, networks, VLSI CAD, as I talked about, and then this area of foundation, which is generic. And notice now that we have some of these machine learning courses, and I may be adding more machine learning courses onto the foundations, because we think, again, that connection to machine learning is going to be critical in the future. You can take 2 599 courses, 8 units. I think we may end up trying to expand this because we have a lot of these 599 courses. 4 units of 590. I highly recommend, if you can, become familiar, get to know one of the faculty, do directed research with that faculty. This is one way to distinguish you from the quite large number of master students that we do have in the program. Gives you a little bit of experience in research. And if you ever think about getting a PhD or whatnot, very useful. But the bottom line is that the field is still evolving, and as such, you can't think of this degree as teaching you a bunch of facts and skills. You have to think about this degree as setting you up for a lifelong journey of learning. And as the field evolves, you need to evolve with it. And that's important. And then there's a seminar course with advisor approval that may be counted towards the 20 units. Right? And then there's some that we allow for transfer and things like that. Okay. All right, and as I said, compared to EE, there's an emphasis on these 3 areas. So we can go into more details. So you need 20 units in this from the 3 listed below, including 1 course from 2 of the 3 areas. So what does that mean? So if you're not a big networks person, I'm not a huge networks person, you could be focused on VLSI CAD and architecture and not take anything in networks. Or if you don't want to go into the weeds in VLSI CAD, you could be in the architecture and networks domain, okay, to cover this. But you need to at least cover 1 course in each of these topic areas, okay? So then we can go into more detail here, right? And then electives from foundations will also count. And this is where we have, let's talk about foundations to start with. So I think I've tried to outline what I think of computer engineering, this boundary between a programmer and a hardware person. What do we think that are general courses that will be very useful at that boundary to set sort of a foundations? Here are some of them that I've listed. Operating systems, okay? So this is the basic underlying program that's running on a piece of hardware that will, run Unix, for example, right? This is sort of the boundary software layer that you have with your CPU or whatnot. So this is very useful, right? It's a CS class, but we consider it part of the 20 units. Again, that's the difference a bit between the MS in EE and the computer engineering areas, that we see in computer engineering a little bit more need for certain software classes like this one. Probability in the statistics, 503, critical. There's still a lot of probabilistic aspects to understanding many aspects of computer engineering. This level of math, the simulation of these kinds of things, and the linear algebra, all of these math concepts we consider foundational, right? And math lasts forever, so highly recommend it as many as you can. And then right now we have these two machine learning type optimization for the information and data sciences, 588 and 660. And there's probably going to be another one that we add on here, the deep learning course will be probably added here as a foundation. For now, if you want to take something that's not here, that's kind of similar, but it's just new, we haven't updated yet, that's where the special request form comes. And they get routed to me, and if it looks good, I generally approve. Okay, so you can sort of see what our thinking is. We believe a good software foundation is important. Math is always very useful, and then machine learning. Those are three areas of foundations. And they all can be counted towards this 20-unit requirement. Then if you go into the computer architecture, the first one, let's talk in more detail. And again, if you have questions, throw it in the chat. I hope it'll show up. Gabby, if there's something that's someone has a hand raise or whatnot, feel free to interrupt me. But I can go over it. So in the computer architecture space, we've got a wide variety of courses. Not all of these courses is taught every semester. You do have to look at both the catalog and the schedule of classes, but many of them are taught at least once a year. 451, Parallel and Distributed Computation, is one. It covers a variety of ways that you may see a program run on parallel computational units, multi-CPUs, and things like that. 454 is our Introduction to System on Chip. That'll cover including accelerators and networks and different I/O devices, and maybe a graphics processor, and how one thinks about this, how you model the traffic, how you design these things. It's a course which actually we're evolving, but it's a common one that students take. Many of you take 457. I would say it's one of the core computer architecture courses. It's taught by Professor Privata. It teaches you the basics of a microprocessor. And of all these, this is the one absolutely, if you're going to be something about a computer architecture, you probably want either to have this knowledge from an undergrad or take it here. It's a lot of work, but it's very useful knowledge. We also have Wireless Internet and Pervasive Computing, Network Processor course. This one I think is going on right now. We have 2 sections of Internet and Cloud Computing, taught by folks from our ISI, Information Science Institute. The Advanced Computer Architecture class, going into even more depth of how people accelerate computer architectures with different, techniques. And I think it goes a little bit further also into multi-CPU. We have the 560, which is sort of like an advanced Verilog system design class taught by Gandhi Privata, often in the summer. Also highly useful. A lot of our students, when they come out of this program, end up being hardware designers. Their day-to-day job is writing Verilog, and this is the course that'll give you that kind of experience that you need for it, as well as teaching you concepts like crossing clock boundaries and things like that. See someone else wanting to join. Okay, and if you're joining late, we are taping this and it'll go out. So we have one in the applications for machine learning. This is not often taught, but it's listed under the computer architecture class. This is now being taught this semester, Advanced Topics in Microarchitecture/Architecture. We're evolving it. And again, this is where a lot of the advanced topics like accelerators will be covered. And a bunch of other ones. Interconnection networks has not been taught in a while, and I don't think the VLSI architecture one has been taught in a I'm not sure about these other ones. So the main ones here that are regularly taught, the 400 level ones, 457, the cloud computing, the network processor design class is quite common, 557, 560, and now, fortunately, this semester, 653. On the network side, we have the basic broadband interconnection computer networks, and I do highly recommend, if you want a general understanding of computer engineering, this is a great class to take. We also have some other classes here, like the 533. This is the overlap network processor design class. Two other common courses that are covered here, data networks and broadband network architecture. And I think, at least I think 555, it's got a smattering of students right now this semester, but it's going to be hopefully taught this semester. And then some of our faculty are into wireless networking and have taught in the past some wireless network. I do not know if they're taught this semester. Maybe, again, irregular. These are taught irregular. On the VLSI CAD side, the intro course here, if you don't have a strong VLSI background, is our 477 class, our mezzanine class. Some undergrads also take this class. It's this semester taught by Dr. Parker. Great introduction to VLSI design, a little bit of transistor theory, a little bit of layout, all good. We have a variety of mixed signal analog type circuits here, modern state solid devices course here, asynchronous VLSI design that in the past I've taught, and now I have a colleague from Intel who teaches this regularly. Then if you already have a good background in VLSI design, you jump into the 577A. They'll cover memory design, you'll cover data path design. The project generally is a small microprocessor, 5 stages, very, very good. And this is all manual effort design. And then 577B, you go into a little bit more system level and you start using the real big CAD tools for this. Shaheen Nazarian, Professor Nazarian also covers a system verification class. A lot of our students, when they do graduate, they go to companies like Intel and whatnot, their first job is not designing the next generation processor, but verifying the next generation processor. That requires more skill set in scripting and other software skills and basic understanding of how to verify large systems, and that's covered quite well in this class. There's also, again, that mathematical foundation we have similar to CS 570 in 5E1. Professor Nuzzo, I think, is teaching it this semester. Very strong faculty, knows what he's talking about in this space. We have expanded it to include some neuromorphic circuits. I think this is one that has been taught by Alice Parker in the past. This is the test class I talked about. Sometimes we have other advanced classes here. These are taught irregularly. I think, getting at some CAD aspects, you can get it from 581 and the test class for sure. But when and if these are taught, I think 681 was taught last year. If you have an opportunity, it's great. It basically teaches you what's inside those super expensive CAD tools from Synopsys and Cadence. And then, as I said, the foundations here. So just popping again, you can pick if you want one course in each of these, but the requirement is at least one course from 2 of these areas, not including the foundations. The foundations are as many as you want. So where we see something like machine learning, OS, or something else, and say this is something that I think everyone should take, I throw it in there. Again, 570 is a course that I often encourage students to take. We haven't been able to put in the foundations because it's a course where a lot of CS students want to take, and sometimes we have a hard time getting our ECE students in it. But when they can get in it, and a lot of times they do, I do highly recommend it and will allow it for the program. Let's see. I think that covers the requirements. Again, exceptions to these are taken. You work with your academic advisor and say, is that reasonable? They may say yes, and then they go for me for approval through an online process, and it works out fairly well. Again, I approve most of them. There are cases where people want to take non-EE courses outside of this list. and that gets a little bit more difficult. If you want to take a course in the business school, or if you want to take a course in ISE, I have to look at it a little bit more carefully, make sure that it's aligned. Because this is a bit more specialized program. It's not an MSEE, and as such, it makes sense for the courses here to be a little bit more specialized, right? So, you know, if you wanted to take something outside of EE, outside of the related CS, that would be a question. But students have said, hey, can I do databases? I typically allow it. There are other courses in machine learning in CS. I typically allow it. So there's a lot of still flexibility within this program. We do think it's a great program. We think it's an important area of distinction between EE. And so we want to encourage students to take it. And that's where it is, right? Yeah. Yeah, so there it is. So it's a little bit more specialized, as Gabby indicated in the chat, right? Okay, so that's sort of a quick spiel, right? Maybe not so quick, but you know, I'm more than happy to go into more details, give you some feedback or questions. If I can answer questions, you know, I think this is, you know, if you ask me, is the area hot? It's very interesting, I think, but I would say this area still has remained to be a good area for jobs, a healthy area, and I can't quite explain why. Even through the recession, there are still a demand. Maybe it's because of the, you know, the IoT world. People were, you know, a few years ago, there's a huge demand of building specialized chips in the IoT space. There's still a huge demand for people who know FPGAs. There's still a lot of challenges out there. Again, people who know the boundary between programming, software applications, and hardware are still needed, right? And again, if you're in the CAD space, that's even harder. You need to be good at both the software, the math, the algorithms that you're implementing, and the hardware, because you can't do it without understanding the hardware. And that's a very nice specialized niche, and there's still demand in that, in my view. Right. So whether you could do so we are a little bit more flexible in terms of the number of CS classes. So I suspect you can take more CS classes as MSc&G than MSEE. And you're just signaling to your employer, because the distinction will be on your resume, your MSc&G. So they will see that you're focused on that. But it really is, I mean, if you said, look, I could get all these things and get an MSEE, it's really a matter of what you're signaling to your employer, right? Do you see yourself as a generalist, or do you see yourself as someone who specializes in computer engineering, right? I think for some applications, there's a value here, right? But in the end, you know, the employer is going to see that, and then hopefully you'll have a section on your resume which is relevant courses, right? And they're going to look at your GPA, and they're going to look at other aspects, and they're going to look at your projects, right? So it's only of what they're going to see. Again, because it's computer engineering, I think you may be able to take a few more CS classes than maybe an MSE. And Gabby, you can correct me if I say anything wrong. Please do.
No, I think that's fair.
Okay. No, yeah. Any other questions? Any other thoughts?
One question was, do you have any CS courses recommended other than 570?
Okay, so there's some machine learning courses that are not bad. I talked to your seniors to see which ones are good and bad. It kind of depends on the faculty and many other factors. Databases is another one that I think is useful and to consider. If you don't know how to program, there's CS455, but we don't allow it. It's just sort of like, you better already know how to program, right? So there is that issue, but you know, there is CS455 that teaches you program. We now also have some 2-unit courses, though, here in ECE that are software principles. And we may be able to, again, special request those as part of the foundation list. So if you end up, you can look at what we have, a 2-unit one being taught by a faculty this semester, Araste Fashami. Shaheen also, I think, teaches a software principles class, and I typically can get those in special request. I'm trying to think about other CS courses that I know about. Those are the ones that come to mind. But there may be others. But those are the ones that come to mind.
Okay. The next question is, can you outline the process and timeline of changing to the computer engineering major? I'm a first semester MSCE student already taking some MSCNG foundational courses. So we usually recommend that you complete your first term here, and then we'll go ahead and have the grades be posted and then contact your advisor, and then we recommend whether or not to switch over, and then we can give you the paperwork to do that. You do need to maintain a 3.0 GPA.
And then the courses for embedded systems, is that the next one?
Yes. What kind of coursework would you recommend if someone wants to pursue a career in embedded systems?
So again, so embedded systems, you really do want to understand the hardware. So 457 is good. 454, I think, is another one that would be a very useful course. Which one is that? I go back to my page here. We don't have specific courses, let's say, in firmware. Where did my page go? Where's that? Hang on a second as I find my. Find the page there. Let's see here. Come on, man. Is it? So for embedded systems, you know, again, you're doing the software, so you should understand 457. I think OS would be also very useful for that. And then I think 454 was that. Let's see. 454 would be useful. Introduction to computer networks, understanding the connections to networking that you might have in embedded systems, because you're going to be talking to people here, and maybe even this network processor design will get into the firmware kind of aspects, at least for some aspects. Those are the ones that come to mind. Right? But yeah, an embedded system could mean many things, right? So you're talking about firmware that's running on an embedded device, but there still may be some amount of OS stuff going on in that device. And there may be other aspects. So I think, you know, this is what I would have thought. Again, Gabby, you might correct me if I'm wrong, but from my knowledge, that would be good. Again, I also think the FPGAs is a good area there, because a lot of embedded systems will be accelerated by FPGA, so 560 would be very useful. Will 533 be offered in the spring 2021?
I can check in the meantime. I don't
have an immediate answer.
I don't have it.
533 is, I have to look at where that one fits. Network processor. This is normally taught by Young Cho, and I do plan for it to be taught. I'm trying. You know, it's not a regular full-time tenure track faculty that teaches this, but the person who typically teaches it is slated to teach it in the spring. So no promises, but I'm trying. It's a good course. 554. 554. One's 554. Now you,
Is that course, is it cross-listed? I've not heard of that class.
all right, I'm gonna have,
Can you just double check one more time to see if this is the correct course?
I'm doing a Google search now. I don't remember, real time. Not sure. We haven't taught that in a while. Certainly we'll look at it. It's a good one, but I think we're trying to, Paul Bogdan might be the right person, Gabby. We're talking about that. I just don't know if it's going to happen. We have been talking about revamping this course to more of a also embedded, also to maybe think about it like a CPS level, cyber physical systems angle here. And so we are thinking about revamping this from its previous notions, and we have faculty that are interested in doing it. But given everything going on this semester, I just do not know if it's going to happen. So I can't promise it, but aware of it, know about it, working on it.
Do we have any more questions from our participants today? We have another question for MSc, or did you read it? Okay.
Computer graphics class. Yeah, I probably would approve that. Right, there's gonna be a limit on how many CS classes, but I probably would consider computer graphics fair game. And one of the reasons why I would say computer graphics is a fair game is that it's extremely computationally intensive. And so you very well may be someone who, who needs to think about what hardware should be there to accelerate the computer graphics, right? We have, many aspects where this can still play a role. The low power implementations of these things may become more as we want AR and other aspects. So I can see an argument why computer graphics should be allowed as those 8 units. But that's a CS class. I'd have to prove it, but it can be.
Okay, the next question is, by when can we change our major to CE? So you have to at least complete 1 semester with our department, and then we check the grades, and then we're able to process the change. So it has, at least 1 semester has to take place.
And then, but how late, Gabby? I mean, if they satisfy everything, and then, after their 20 units, look, I could actually have, I've fulfilled everything in computer engineering. Could they just switch late in the game?
They can. We would probably recommend the latest at the end of the 3rd term, so that we can double check that all the requirements are complete, and then also their application to graduate will be correct. So they apply for the correct degree.
Okay, hopefully that answers that question. Keep these questions coming, guys. We really do want to be helpful in it. We recognize that you can no longer just walk into student services. So these forums are the only way sometimes that you can get your questions answered. And you have to recognize that some of your questions your other fellow students will have. And so if we can answer it once in forums like this, it makes it better for everybody. So a lot of times people say, well, how do I do DR? If you're interested in DR, directed research with a particular faculty, you need to send them your grades. If you have GRE scores, you could even send them your GRE scores, send them your CV, check out their webpage, talk to, if you can, any of their students who might be TAs in your class, for example. Get to know them as best you can, and put yourself forward. Say, hey, look, I'm interested in doing DR. Do you have any projects that fit my background, right? And you'll be surprised. I mean, I actually take probably 4 or 5. Actually, this semester I have 7 DR students. So it won't typically happen your first semester, but depending on how well you do, what courses you take, and the faculty's interest, it can happen as early as the 2nd semester. And I usually try to recommend my DR students to do it for more than 1 semester, because it often takes a while to ramp up on research. So splitting the DR across 2 semesters is usually a good thing and a better thing. And my take on that, just to give you my own take on it, is that your goal should be to become a co-author on a paper. Having yourself published will distinguish you from your peers and make it that much easier to get a job when you finish. So the PhD side, I view a PhD as a bit more mathematical than master's program. And so if you're interested in a PhD, then my view is you need to certainly think about 570 in computer engineering, maybe a 581, certainly 503, and then maybe some of the machine learning, which is more math. But I always, even in computer engineering, I kind of think of it as applied math. We're trying to solve problems of computer architecture networks, VLSI CAD, and we're trying to find what is the right math tools to solve those problems and then how to code it up and get it done. And the difference between master students that could just be thinking about just designing a block or designing a chip, the design aspect doesn't require that strong math skills. So the distinction I would say in this space, comparing the two, is that the PhD student has demonstrated a stronger desire and capability of handling the more complicated math. I hope that answers your question. Will the usual number of courses offered in spring increase since many students defer to spring? Really good question. I don't know that we know, to be honest. I think that our goal we still have all the faculty that are teaching. I think that what's going to happen is we're going to have to play games with a number of sections, right? So for example, we have fewer students this semester starting. So that may mean that we have fewer sections of certain courses this semester. And that will mean for the follow-on sections or courses next semester, we may have fewer sections. But I don't see us dropping courses. I see we still have a full array of computer engineering courses that we're going to be teaching. RF, SDR, software-defined radios, and RF. So there's the 536A and B. And then as one of those 8 units of electives, I think there's something in there's a mobile networks class, or a mobile, yeah, I think it's a mobile class. A more general class in in basically our comm division that I would recommend. And I would say absolutely I would allow that again as part of those 8 units, right? So those 8 units can be somewhat more flexible. And this is, again, you need hardware, you need good hardware, you need to understand the hardware to do a software-defined radio, right? Absolutely, if there's a course like that, that should be considered as part of the elective. Other questions? I think we've got a good number of them. And hopefully, again, Gabby, you're protecting me from not saying anything too wrong.
Oh, you're okay.
All right. I do, I think that there's a lot of flexibility in computer engineering, and yet there's still an emphasis, right? There's a core emphasis on what you want to be able to do, but then because we're the hardware platform of all these different domains, there's flexibility on the application space. If you want to find a job in computer graphics architecture, which courses? 457, 557, maybe there was maybe even 560, 577B, and if you didn't have A, that's also there. Then now we need to even think about, there may be other classes as well. It depends on how far out we are looking. There's a new memory class taught by some of my colleagues over at EEP. I think his name's Han Wang. That could become more important. We don't know, but there's new models of memory and stuff going on there. And then there very well may be, if you're doing computer graphics, there's probably a CS class or 2 that you're going to want to take so that you understand the hardware algorithms that are accelerated. But you're going to still need the foundations because even a computer graphics architecture is a pipeline. You'll need to understand 457, 557 concepts for that, no doubt. And then typically, yeah, you want VLSI. So the 577A, B, digital, you're going to need that. And then there's some ancillary ones that may be relevant. Right? Anything else I can answer? Is Gabby, would you say there are other courses I haven't hit on that you think are popular that should be mentioned?
That are popular.
Or that you think are important?
Robotics is a big one, and for some reason, but that's...
Which one?
Is it robotics?
Ah, I did not mention that. That is another area. So we have a new faculty in the robotics area. So on the CS, there are robotics, absolutely need hardware for robotics. So if those of you who want to get into the robotics area, ask for a course in robotics, that also can be approved as an elective with ease. With ease. I have no problems. I think it's quite important and quite useful. And that also gets into the embedded system area, right? Because a lot of a lot of the robotics require embedded software to run. So understanding the requirements, the real-time requirements, the kind of algorithms that need to be run on robotics does connect with the embedded system space.
All right. Do we have any more questions from our participants? Okay.
All right. Well, again, I hope everyone found this somewhat useful. Again, it's my take on it, but I'm also the person who's generally approving these special requests and extensions. And hopefully I conveyed the range that these things are possible. And hopefully you guys are interested. I think it's again, an important area, a good specialization to consider.
All right. Well, thank you, Peter, for giving us this time to review the requirements. We really appreciate it. And this is a recording, so I will go ahead and work with our IT personnel so that they can go ahead and place it on our website.
All right, guys, take care. Thank you so much.
Thank you so much. Have a great afternoon, everybody.
Bye, all. Get out of here. Do that.
All right. Thank you, Peter. I went ahead and I'm going to go ahead and edit the recording, and then I'm going to hopefully ask Ben to help me upload it on the website.
Awesome. Okay. Take care.
Thank you. Have a great day.
You too.
Bye.
Bye.